Hi students, good morning. Welcome to my YouTube channel. Students, in this video class, I am going to teach you exercise problems related to polynomials. So exercise number 2.2, second main. So the second main is find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. Students, once again I will repeat the question. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. Students, before moving to this example, we can find the general form of quadratic polynomial when the sum and product of its zeros are given. Students, we know that the general form of quadratic polynomial is ax square plus bx plus c is equal to 0 is the general form of quadratic polynomial. And also we know that the relationship between coefficients and zeros of the polynomial. So sum of zeros of polynomial is equal to minus b by a and product of zeros of polynomial is equal to c by a. So it is a general form of quadratic polynomial. Ax square plus bx plus c is equal to 0 is a general form of quadratic polynomial, and here alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a is the relationship between coefficients and zeros of the polynomial. So this is called equation number 1. Now divide a throughout equation number 1. Divide a throughout equation number 1. Then equation number 1 become ax square divided by a plus bx divided by a plus c divided by a is equal to 0 divided by a. Now here a get cancelled, the remaining term is x square plus b by a into x plus c by a is equal to 0. Because 0 by anything is 0. Students, see here alpha plus beta is equal to minus b by a. What is b by a? B by a is equal to minus alpha plus beta. Yes, this equation become x square minus alpha plus beta into bracket x plus c by a is nothing but alpha into beta. Yes, alpha into beta is equal to 0. Yes, student, this is the general form of a quadratic polynomial. General form of quadratic polynomial when the sum and product of its zeros are given. So in case sum and product of its zeros are given, we can take this as the general form of a quadratic polynomial. Yes, sir. Then next, moving to the second bit. Second bit is find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. In that the first question is 1 by 4 minus 1. 1 by 4 minus 1. Solution. Students, here 1 by 4 is a sum of zeros. Alpha plus beta is equal to 1 by 4. And minus 1 is a product of zeros. Alpha into beta is equal to minus 1. Okay. But we know the general form of quadratic polynomial when the sum and its product are given. That is x square minus alpha plus beta into x plus alpha into beta is equal to 0. X square, but we know alpha plus beta is given in the question 1 by 4, so minus write as it is 1 by 4x plus alpha into beta is minus 1 into bracket of minus 1 is equal to 0. Now x square minus 1 by 4x plus into minus 1 is equal to 0. So it is x square by 1 and here 1 by 4 and 1 by 1. The denominators are 1, 4, 1. Therefore the LCM of 1, 4 and 1 is 4. 1 how much is 4? 1 4 is 4. 4 how much is 4? 4 1 is 4. 1 how much is 4? 1 4 is 4. 4 into x square? 4x square. Minus 1 1 is 1x. Minus 4 1 is 4 is equal to 0. Now this denominator moves to right hand side. It become multiplication. 4x square minus x minus 4 is equal to 0 into 4. But we know that 0 into anything is 0. So 4x square minus x minus 4 is equal to 0. So it is our required quadratic polynomial. Okay. 4x square minus x minus 4 is equal to 0 is the required quadratic polynomial. And next, move to the second example. Second example is square root of 2 1 by 3. Solution. Students, here the first one is sum of zeros, that is alpha plus beta. Alpha plus beta is equal to square root of 2. And the second one is product of zeros, alpha into beta. Alpha into beta is equal to 1 by 3. And we know that the general form of quadratic polynomial when the sum and its product is given by x square minus alpha plus beta into bracket x plus alpha into beta is equal to 0. Okay students, write x square as it is minus alpha plus beta means what? It is root 2. Alpha plus beta means square root of 2 into x plus alpha into beta is 1 by 3 is equal to 0. And here x square divided by 1, square root of 2 by 1 and 1 by 3. The denominators are 1, 1 and 3. So the LCM is 3. Okay. 1 how much the 3? 1 3 is the 3. 1 how much the 3? 1 3 is the 3. 3 how much the 3? 3 1 is the 3. And now 3 into x square is 3x square minus 3 into root 2 is 3 root 2 into x plus 1 1 is a 1 is equal to 0. And here the denominator moves to the right hand side, it becomes multiplication. 3x square minus 3 times of root 2 into x plus 1 is equal to 0 into 3. And this becomes 3x square minus 3 times of root 2 into bracket x plus 1 is equal to 0 into anything is 0. So 0 3 is a 0. Therefore, the required polynomial, quadratic polynomial is 3x square minus 3 times of root 2x plus 1 is equal to 0. This is your required quadratic polynomial.